All right, we're going to write an algorithm that finds the magic index in a sorted array of integers. So what that would look like is if you have -1, 0, 1, 4, 8. Well, I don't want to go that too high, but like -1, 0, 1, 4. Actually, let's do 1, 3, 5, 9, 12. Okay, then a magic index is where the contents within that index so match the index number. So in this case, it would be the 3s. So the big clue here is that it's a sorted array, which when they say sorted, usually you can think, can I do a binary search? And in this case, yes, you can, because what we can see is that every number that is less than our magic number has an index that's greater than its contents. And every number to the right of our magic number has an index that's less than its contents. So given that, then we can go in and test with the indexes. So to do that, what we can say is, first we can do like a little helper function to get it started. So just call it find magic. And it takes in an array of ints. Okay, and we can do some little tests on that just to make sure it's okay. So if array.length equals 0 or it's null, we can, throw an exception or just return -1 or something like that. And then we can then go in and say, okay, we want to return our search. That's where we're going to call our search, and it's going to take an array. It's going to get 0 for the left, and it's going to get array.length -1 for the right. And that's what we will return. Okay, so then let's go ahead and write our search. The first thing that we will do is, it's going to return an int. And it's going to take in an integer array, the left, and the right index. Okay, so what we know we need to do is make sure that left is always less than or equal to right. Okay, and then we can go in and we can calculate our mid. And that is left plus right divided by 2. If we can check and see if they're equal. Is it a magic number? So if array at mid equals mid, then this is kind of where we can get kicked right out of the algorithm. So we're going to return mid. If mid is greater than array at mid, that's when we know that that we want to throw away the left side, because we know that we're on that side of the magic number. So if array of mid is greater than array at mid, then we would go look to the right of there. So then, and the right. Okay, and then else it's less than. So we would array at left and mid minus 1. Okay, now if we get to a point where we never hit any of these and then left ends up being greater than right, then we know that we searched the entire set possible and we never found anything. So we'll return -1 since that is not a valid index, and that will kind of be our trigger to know that we didn't find anything. All right, so let's just kind of walk through this and get a different color here. Okay, so we have our first set going through, and it comes in, left is going to start at 0, right is going to start at 6, and then we'll come in. Left is less than or equal to right, so we come in and we say our mid is going to be 3 right here. And this is probably not a great example to go through because then it just goes in, and if mid equals mid, which it does, we're going to return mid and we're out. So let's go ahead and write a new set of numbers that is a little bit more interesting, but we'll make sure we include negative and positive numbers in that. Okay, so let's try -2, -1, 0. Well, actually, let's skip a few. I don't want to accidentally. Okay, and then we've got 1. We'll do 2, 3, 5, 8, 10, 11. Okay. All right, so again, we've got our sorted array, and our target is this 5 right here. So we come in and we can start over with a 1, and we know it's going to start off with left at 0. Right is going to be 8, and mid is going to calculate to be 4. Okay, so we're here. And then we came in, and since it wasn't equal at 4, because 3 is not equal to 4, and it knows that 4 is greater than 3, so our mid is greater than, so then we know we need to go to the right. So then we come in, and left ends up being 5, right is 8, and it comes in, and left is still less than or equal to right, and we get our mid, and our new mid is 5 plus 8, which is, it's 13. So 13 divided by 2 is going to give us a mid of 6 right here. Okay, so our new mid is 6, and we come in and we say, okay, we had returned the 1 was here. The second one comes in, and since it was greater than, or that is our second one. So then it comes in and it's going to hit it at 6 is less than. So that means we're going to hit it here. And then the third one would go in, and we'd have left is 5, and right is mid minus 1, also 5. So we come in, left is less than or equal to right, 5 is less than or equal to right. So if mid Okay, and mid is going to be 5 plus 5 divided by 2, which is 5. And if mid equals the array at mid, which it does, we would return mid. So we'd return that 5. So that seems to check out. We've got our tests for if the array is null and such in our helper function. So we are good to go. And the complexity of this would be a log-n solution because we're able to use that binary search and we're using 0 additional space.